Hey kids, welcome to another day of statistics topics. But again, this isn't accompanied by a live session, so I'm going to go ahead and do the warm up. This warm up was really more of a discussion piece, which of course we can't really do too much discussion this way, but trying to highlight the idea of the different ways statistics can be manipulated to give certain impressions. Right? Both of these people are not lying. Neither of these people are lying. Both of these people are using a measure of central tendency, which is how you describe the middle of the data. But the superintendent's claim, which is again not a lie, takes into account every single piece of data, which is oftentimes a good thing to do, right? You don't want to ignore anybody. But she's taking the sum of all the salaries and dividing it by how many salaries are given. But that means 750 and 25, right? Kind of sort of counted equally, if you will, as opposed to the median, where the median just says as long as you are in the appropriate order, 1, 2, 3, 4, 1, 2, 3, 4, right? So it would be the average of 31 and 28. That is also not a lie. That might be a better representation of most of the data. So sometimes a picture is a good way to describe data. So here are 3 ways you can describe data. And not the only ways, but the kind of the most famous ways. Which picture would you say best represents the superintendent and teachers' data? Right? I hope this one, right? And here's a nice way to think about it, that the mean, if you think about a symmetric distribution, not all symmetric distributions are normal, but a pretty famous one is normal, where the mean and the median are equal. So that is normal. The mean is equal to the median, but if you take the mean away and drag it to the right, that indicates that there were some higher numbers out here, some outliers possibly, that are skewing the data. And that's where the right skewed. And right skewed means the mean got pulled from the middle, because the median's always going to be in the middle, right? The mean got pulled from the middle to the right, where you can see in our case 250 and 175 are up here, but most of the data is below the mean, right? I would say that our data, right, the mean was pulled even a little bit higher. Left skewed data, so right goes with the mean going to the right, going with a smaller amount of data at the top, right? And most of the data being at or below the mean. Left is the opposite, where from the middle, the mean is pulled down to the left, which means you have some outliers here. Again, I'm using the term outliers in general, not by formula, just that they are different from most of the rest. Okay, so let me talk a little bit more about this picture. Whether I have a histogram or I have continuous data, I can use, right, discrete data, continuous data. I can describe that with these words, right? Symmetric, right, left. Yeah, all you have to do is Google. There are some other vocabulary words, some other bimodal, or one that I can remember. I don't remember the rest, but these are the 3 that we want to be most concerned with. All right, so to move on, so make sure you put these in your notes. Okay, think about what the value, what the outliers mean. Get it? Mean. What the outliers mean to the mean. All right, so today we're going to talk about the histograms that you learned how to make in the last lesson. And we're going to talk about using, because after all, histograms are used for large sets of data, right? I don't need a histogram when I have, for instance, that warm-up data. I don't need a histogram for that. But when I have a large data set, I might want to organize it into a histogram. But then if I want to get data off of, some measures of central tendency, some measures of dispersion, I have to take the data back out of a histogram, right? And look at it all individually. So I'd like to be able to do a good job of approximating central tendency and measures of dispersion from my histogram. So I don't have to unpack it after I've packed it all up, or even better, somebody's just handed me a histogram. I would like to do some data and statistical analysis on it without having to recreate the original data set. So here's a histogram of math SAT scores way back in 2005. Modal class, okay? Not asking you the mode. I don't have the original data set. I can't ask you the mode, but I can ask you the modal class. By definition, the modal class is the class that has the highest frequency. It's the highest bar. There it is. That's the modal class, the 1, 2, the third class. Estimate the mean. I just want you to eyeball for right now. I'm going to teach you how to do this. And when I say eyeball, I mean with the fulcrum that I talked about in the end of the last video, right? I just want you to think of balancing. Where would you put the fulcrum to balance this? Would you put the fulcrum here? I don't think so. Would you put it here? I don't think so. Would you put it directly in the middle? I don't know, but maybe somewhere close to the middle, right? A little bit to the left, a little bit to the right. Again, I'm just asking you to estimate, but what I want you to think about is this seesaw balance idea. And certainly the modal class had something to do with my balance, right? Where's the most weight? Right, so maybe approximately, what do you think this is? Oh, by the way, look at these numbers here. That's not how I want you to make a histogram, right? How do I want you to make a histogram? How does IB want you to make a histogram? Class, not limits, but boundaries, right? We're going to talk about what these may mean, though. Right? And we're going to have a use for these numbers. What are they? And how are we going to use them? Spoiler alert. It's up here, and how I calculate the mean from a histogram. Remember, everything I'm doing is an estimate because I don't have the original data. All right, so this is from number 14 from your packet from the last video. So you made this histogram. This histogram has the class boundaries down here, what I'm talking about, electricity used, and the frequency on the vertical axis. Can you see the modal class? 6. Now, what about the mean? Again, I can ask you to approximate it just with an eyeball, right? Balance on the mean. Think of a teeter-totter or a seesaw, and where the fulcrum should be. It's a decent approximation. What would you guess? Maybe probably somewhere around in this modal class, right? So where I put maybe approximately 900, maybe. But so that is the eyeball method, which isn't terrible. But now I want you to I'm going to teach you how to calculate, which is still an estimate of the actual mean. So down here, I've given you, because after all, we did have the original data set, right? It was 50 pieces of data, so I added them all up and divided by 50, and this is what I got. So look, my approximation of 900 wasn't terrible. Let's see what our computations, which are still an estimate, how close we come. So the histogram did come from a frequency table, right? So I can reconstruct a frequency table even if I don't have the frequency table. If I have the histogram, I can get the frequency table. And this is those values I was referring to at the bottom of the SAT histogram. Class mark. We're going to use one value out of each one value. Oh, why is that working? One value out of each class to represent the class. It's like the class representative, right? So the class mark or the mid-interval value, I've seen class mark used a lot more than I have mid-interval value, but it is the average, and I do mean the mean or the midpoint of each class. So can you tell which class I've used here? 770 to 8.5 to 810.5, who have I used? I've used the third class, right? Now, notice I used the boundaries. I used the lower class boundary and the upper class boundary. But do you see that I would get the same number if I used the upper class limit and the lower class limit? Right? I'd get the same number. Right? 5 families were in this histogram bar, but I'm going to use somewhere within there, and I'm going to use this one number, 790.5, to represent all 5. All 5, I'm going to say, so that isn't, there's my error, right? Because all 5 didn't, as far as I know, right, use 790.5, but they were within this range. So I'm just going to use this one number. This is the class mark for the third class. So here, how about let's do this for the first class, right? One family used between 691 and 780. I'm sorry, 730. So I took the lower class boundary and the upper class boundary, found their average, and I'm going to do the class mark. And again, I can also use the lower class limit and the upper class limit. I'll get the same value. All right. So class mark there, 710. And I'm going to want you to do that all the way down. Class mark. So you might want to add that here. And as you do that, I want you to think about the distance between each class mark. First class is 710.5 class mark. Second class mark is 750.5. How far apart are they? 40. Not a coincidence. Because what is 40? Class width, right? Now, when I am talking about the average, go back to, right, my class mark that I found. Any class mark, but this one, I mean, you need to talk about this with any class mark, but 750.5 was for the third class. That was the one number that I was going to use to represent the third class. How many times should I use that? Right? That, of course, goes the same for every class mark. Every class mark that you found, how many times should you use it? However high the frequency of each bar, right? The frequency of the bar. So each class mark should be multiplied by its corresponding frequency. That's how we calculate the mean. You find all the class marks, you multiply each class mark by its frequency, you add all these up, and you divide by the total frequency. So you see a table, I've made a table in your packet. I filled in the first couple of values, pause the video and fill in the rest. Okay, hopefully you have filled all this in, and then I want you to look at the frequency should be what? This sum should be 50. Add all these up, and yes, do this on your calculator. In this sum, I got 44,565. Okay. Now we're ready to find the mean. So the estimate of the mean from the histogram is your column that had your class marks times your frequency. Add that up. Divided by the total frequency. And I got 891.3. Pretty good, right? If we were in class, I would have left you do this together, and you would have turned and you would have checked and make sure that you got this calculation right, and think about how that compares to the original, right? What did I get? 891 is not the exact mean. It is not equal to the actual mean, right? It wasn't at 889, but it's freaking close. It's a little bit better than our eyeball, right? Our eyeball was 900. The real mean was 889. And another estimate, but it's closer to the actual one, is this process. So I have a stop button here because I don't want you to, right? This was still kind of annoying to do with even just using our calculator on our home screen. So I want to go back to the previous slide. And I want to make sure that with a calculator, another way, especially if we had a larger set, you do have to get your class marks. Put your class marks in L1. So you hit Stat, Edit, and put your class marks in L1. Put your frequency in L2. And then go up to L3 and put your cursor on L3, right? So you're up above the list. Put your cursor and make L3 blink and type L1, which is second 1 times second 2, and then hit enter. And it'll fill this column for you, right? Instead of you actually having to do this multiplication over and over again. Then what you want to do, so you want to do 1, 2, 3. Then the fourth step, if you access your list operations, your list operations are when you hit second stat. If you, right above the stat button is written list, so you want to access operations on your list. Actually, you want to access math on your list. So you arrow over to the math. And choice 5 is sum. And if you hit sum, you're back on your home screen with the parentheses, and then you want to sum L3. Forgot where I put it. Sum L3, and you'll get this number. Okay, so that's just a way to get your calculator to help you a little. You already used your calculator to do that, but this way is a little bit faster. Now we're going to do the standard deviation from the histogram following a very similar procedure. So the standard deviation, you know, is the square root of the variance. So really, I have to do the variance. So here's the formula for the variance. For the variance. to approximate the variance from a histogram. Remember, the variance is taking every data piece, subtracting it from the mean. How far is it from the mean? Squaring that distance so you avoid the canceling out, and then summing them all up. Well, now we are just going to take the class mark minus the mean, square it, multiply times the frequency, and we're going to divide by the total frequency. Right? That's the extra piece with the histogram. And then we're just going to take the square root of the answer. So do you remember this number here? Right? What did we get? What do we get? Remember when we did to find the mean? I want you to take that number and I want you to use your store capabilities and store that in alpha A. Right? In alpha A, you should use your alpha button, and A is right there above math. Store that in alpha A. Okay. So I want you to take now, using your calculator, let's use your calculator. Remember, you have your mean stored in alpha A. You have your class marks in L1. You have your frequency in L2. And then your total frequency is 50. So you're literally on your home screen going to type, I'm sorry, not in your home screen. You're going to go to your lists. And let me go back to this screen where your lists are. You're going to go up into L4, highlight L4. So you're hitting Stat Enter, and you go up and make your cursor blink on L4 and type L1, right, second one, minus alpha A squared times L2. Enter. So what that's going to give you is it's going to fill this list with every class mark minus the mean, square that number, and then multiply times the frequency. And it's going to fill those numbers in here. What have I done? What piece of this have I done? Right? I've done that part. I have each individual class mark minus the mean squared times the frequency. What do I need to do now? Total. How do you find the total on that calculator of that L4? You do second stat, which gets you to your lists operations. I don't want list operations. I want to arrow over to math on my list. I choose choice 5, which is sum, but which list do I want to sum this time? I want to sum L4. That gets me this piece. And what do I want to do with that piece? Hit enter, and then what? Divide by 50. What do I want with that answer, though? What did you just get? You got the variance. I want standard deviation. What are you going to do with that number? You're going to square root that number. And you're going to hit second x squared, second negative, because the answer is above that, and you will get 83.9. Whoa. So approximating the mean and the standard deviation from a histogram. A lot of calculator, right? Keystrokes. So practice those. Make sure you make note of them and practice them. And it becomes, if you understand what what you're actually doing, when you forget, where am I supposed to store? When was I supposed to go to the list and whatever? If you think about what you're doing, right? You know what the variance is. And then just how to make your spreadsheet, if you will, do it for you. All right, so we did approximating the mean from a histogram, approximating the standard deviation from a histogram, and now we're going to approximate median and quartiles, percentiles, deciles. But we're, yes, going to do it from the histogram, but really we need the frequency table. So but if somebody hands you, firstly, if you made the histogram, you had the frequency table to do it. If somebody just hands you a histogram, it's pretty easy to get, it is easy to get the frequency table from it. So look at what I've done here. I have all, right, the same data from number 14. I have all my class boundaries in here and all the frequencies. But now I'm going to add a third column called the cumulative frequency column. And I'm going to fill this in with what numbers? Can you see what I'm doing here? Frequency here was 1, but then the next class had a frequency of 3, so the total is 4. 1 plus 3 is 4. 4 plus 5 is what? And so on and so forth. And this should not be a surprise, right? That's the check to make sure you've done it right. Your cumulative frequency should be 50. So now I'm going to make a graph of this cumulative frequency table. To make a graph, I have to choose an, right? This is 2D. I have to choose a horizontal value and a vertical value. Can you tell who I've chosen there? $650, $700, right? Started kind of low here, right? A little bit lower here and a little bit higher here. And then what's along, right? Frequencies, right? Ending with 50. Cumulative frequencies. Now I'm going to plot points. So what points do you think I'm going to plot? Well, I am going to plot my cumulative frequencies, certainly. This is a cumulative frequency table, so those are going to be my dependent values. What do you think my independent values are going to be? Well, it's not going to be my frequency because I'm doing cumulative frequency, so it's got to be something here. What do you think? It would make sense if it was the class mark, but it's not. How come? I don't know. It's just the way that this is defined. Your independent values are all your upper class boundaries. And actually, just to be right, look at what I used if 690.5 is my first lower class boundary, well, if you imagine the case before that, right, the upper class boundary of the class before that would have also been 690.5 and it would have had 0 in it. And that's so you can just start your cumulative frequency diagram your plot at a 0. So ogive, you want to put that in your notes. Ogive is a name. IB loves this name. I'd never heard of it before IB. I'm sure maybe I ran across it when I took statistics in college, but I don't remember it until an IB. I saw it on an IB exam. And ogive is just the cumulative frequency graph or diagram. And it is the data from your cumulative frequency table, right? Cumulative frequency table adds the sum of your frequencies as you're going along. And then you're going to plot 730.5, comma 1. Actually, I'm going to plot 690.50 first. Then 770, right? And so on and so forth. There's my ogive. And I'm going to connect my ogive with a smoothish curve. Oops, sorry. Not what I wanted to do yet. Notice the kind of SE component there, right? And where does it level off at? 50. So why do I want an ogive? This is how I am going to approximate the median, which is, right, force, tenths, cutting it into tens, cutting into ones, cutting it into fours, cutting it into halves. This is the table that they're going to want me to use to, and graph, to estimate those. So how do I do that? You have to find your position. So to approximate the median for these 50 pieces of data, it's 50% of the way through the data. So you take the 50 pieces of data that you have and multiply it times half, right? 0.5. Right? For the quartiles, you're going to take your 50 pieces of data and multiply it times 0.25. Okay. For the percentiles, you're going to see which percentile I want. Same with the deciles. But you're going to go to the graph and you're going to say, well, if I, 50 times 0.5 is 25. That's the position. So go to the y-axis and find 25. 2245. Go across to your cumulative frequency and down to the x-axis. This is approximately Q2 from the ogive. IB is going to want you to approximate from an ogive. They're going to want to see you make the ogive, and they're going to want to see these drawings, right? They're going to want to see you go from the Y over and then down to the X. Okay, so first you get the position on the Y-axis. You go over to the ogive, down to the X-axis. So what's 50 times a fourth, though? Go to that position, 12.5. Over to the ogive, down, right on what I have here, 2, 4, 6, right? So what is that, 820, 815, something like that? Approximately Q1. All right, and of course I could repeat this for, whatever I asked you for. But this is the main, when they ask you to approximate your median or your quartile or anything, when they give you on this is what they want you to see. Get the position, go to the y-axis to find that position, then go down, and then go across to your ogive, go down to the x-axis. I can do this on my calculator. I can graph an ogive on my calculator, and what I do for that is I put this list into L5 and this list into L6. And then I can hit, when I go to stat plot, turn my plots on, and then tell it I want it to do a connected graph, which is that last choice there when you see type. And then I change the X list and Y list to L5 and L6. And you can see and of course manipulate your window, right? Your X min would go from 650 to 1100. Your Y min would go from 0 to 50. And you'll see your ogive there. So again, this is on the back page. What did I do? The median is 50% of the way through the data. So again, I am starting to kind of treat it as continuous. So there's the step 1 that I did. I took the 50 pieces of data and I multiplied it times my 50%, and I got 25, which is a position on the y-axis. And I drew a horizontal line till it met the ogive. Vertical line down to the x-axis, and that was the approximate of Q2, or the median. So I could, again, I could ask you for a bunch. We did this one already, right? I did this on the graph. I said our original piece of data times the Q1 is in the 25th position, or 25% of the data, I should say. And I got 12.5. 12.5, I went across to the ogive and then down. I wrote 830 down on my paper. I don't know if that was right now with the whatever. How are you going to get Q3? You're going to take 50 and multiply it by what? Now, remember, every time you do this calculation, you get the position on the y-axis. Across to your ogive, down to the x-axis, and you're approximating Q3. What did I write down? I wrote down 940. So what's my interquartile range then? The estimate of my interquartile range, 940 minus 830. Right, so look at all the data I can get from the histogram. I should be putting units on all of these, shouldn't I? The 23rd, oh, that's pretty close to Q1, shouldn't it be? 23rd percentile. So the 23rd percentile, first I have to figure out, well, what is that? That's, remember the formula that I gave you before? That's 23 out of 100 times, not 50, times what? 51 gets me my position. Went across. And down. And I got something close to Q1 as I expected. Okay. Decile, what are you going to do for decile? What's your decile computation? 4 out of not 100, but 10 times n minus 1 That's my position. Across, down, right? I think you get it now. All right, so the homework that goes with this is not like the, it's not the huge packet like the first one had been. So this is reasonable. Please go ahead and do it all. Where I give you frequency tables and ask you to find the mean. Please do go ahead and practice using your lists and your and your calculator and your statistics capabilities. Then I ask you to, I don't think I asked you to do no, I didn't ask you to do standard deviation. I just asked you for the mean. Then I asked you to do the cumulative frequency table. And then create an ogive and do some of these approximations from your ogive. Okay? All right. I hope you had some restful days away from your computer. And I will see you in our next live session. Oh, thought that was the end. Now it's the end. Don't forget to get your position first when you're doing your estimating from the ogive. Bye.